To help get you all more familiar with truth tables, I want to run through one more example, and this time instead of showing steps, I'm going to run through it in real time. So the instructions here are construct a complete truth table to determine if the following argument of truth functional logic is valid or invalid. The argument we're going to look at has two premises. If A, then B, not B and not C. And from that, we're going to conclude not A. So the test is for validity. So when I look at this, I've set up the table already just to shorten the process a little bit. And my first step is going to be look through the argument and see how many different simple statement letters there are. So I see A, B, and C. So I need A, B, and C in my first three columns. I apologize that this is going to come with the sound of typing, but that's what comes with it being in real time. Once I've got all of the possible simple statement letters that are going to appear, I want to copy over the sentences themselves into the other three columns so that I can later determine their truth value based on the truth values of the atomic sentences. So this just takes a little bit of editing to get them all correct. And I make sure to put my conclusion in the last box because to evaluate validity, we need to know whether or not the conclusion is false when the premises are true. So we need to be able to distinguish which one is the conclusion. And now I'm going to go through, I've got the basic layout. I'm going to go through and set up my valuations. So here I have three simple sentence letters. So I need 2 to the power of 3 rows. So that's 8 rows. So let's make sure that's right. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then I make half true in the first, half false in the second half. And then I do half in a row, so I did 4 in a row, and I'm going to do 2 in a row. False, false, true, true, false, false. And that last row will always be alternating true, false, true, false, true, false, true, false. That gets me all the possible valuations I would use. Now I can go on to determine the truth values of the premises and the conclusion. I'm going to start with the conclusion because it's the simplest sentence. So it's the negation of A. The rule for negation is take the sentence's truth value and flip it. So since A is being negated, I just take the opposite of what's here. So this will give me false, 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 and then true, 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 true. That completes my conclusion row. There are no other logical connectives, so I don't have to worry about anything else there. There are a couple things just to mention along the way. The first is if I were doing the partial form of the validity test, I wouldn't actually have to look at these lines anymore because the conclusion is true in them. So they can't fail the validity test. They can't be rows where the premises are true and the conclusion is false because we already know the conclusion is true. It doesn't matter what the truth value of the premises are. So we can actually insert a little check mark in them. So I can check all of these rows off. Oops, there we go. But just note that for these instructions, they say construct a complete truth table. So for the purposes of illustration and because of the so-called instructions here that I've given, I am going to complete all of these rows. But if you were completing a partial truth table, you would only need to look at these ones. The next column I'm going to look at is the first premise. It's the next simplest one. So it's the conditional if A, then B. What do I know about the rules for conditional? The conditional is only false when the antecedent is true and the consequent is false. So I know that when the antecedent is false, the conditional is going to have to be true. So that will be those last 4 rows. Since A is false, the conditional, if A then B, has to be true. That takes care of that. Then in the first 2, A is true and B is true, so those are each going to be true. However, in this 3rd and 4th row, A is true and B is false. That's what makes the conditional false. A true antecedent and a false conclusion. So these 2 rows, this conditional will be false. Now again, if we were doing the partial truth table, these 2 rows would actually be done. Why is that? Because an argument only fails our validity test if it has all true premises and a false conclusion. So when there's one false premise, that shows that that row doesn't fail our validity test. So we can check both of those off now too. Again, if you were doing the partial truth table, you wouldn't have to do any of these rows under this column for not B and not C, but we're going to do the complete truth table here. For this first premise and the conclusion, we only had one logical connective in each one, so we just had to use our atomic sentences and the rule for one logical connective. But this one has 3 logical connectives, so we're going to have to think about scope. What connective takes widest scope? It's this conjunction. So I'm going to put that in bold. And maybe let's make it red to make it clearer. So the main connective is the one I do last. What does the main connective link? It links the negation of B and the negation of C. So not B is one conjunct and not C is the other conjunct. I don't know the truth value of not B until I calculate it. I don't know the truth value of not C until I calculate it by relying on C and relying on B. So for not B, this is my narrower scope connective, and each of these in the conjuncts take equally narrow scope because they're both in the conjunct and there's nothing narrower than them. So I'm going to start with not B, and I'm going to go down and take the opposite truth value for B in each of these. So that would be false, false, true, true, false, false, oopsie, mistype, false, true, true. Now I could do that very quickly because I remembered what the pattern for B was. 2 trues, 2 falses, and I just have to swap it all the way down with the negation. Now I want to go under not C because we have to determine the truth value of both conjuncts before we can determine the truth value of the conjunction. So let's go under the negation for C. And we're going to have, again, the alternating truth values. So when C is true, not C is false. When C is false, not C is true. We have to go all the way down the line. False. C is false. Not C is true. C is true. Not C is false. Easy to make slip-ups here, so you have to watch carefully. And then C false, not C is true. Now that I have the truth values of both conjuncts, I actually don't have to look at any more of these rows because this conjunction depends on the value of not B and not C, which we've determined already. So I am going to try and do bold and colored red to indicate that this is the main connective. False and false makes the conjunction false. False and true, the conjunction is false. True and false, the conjunction is false. Remember that the conjunction is only true when both conjuncts are true. So we see that in this row. Again, not B is false, C is false, so that's false. We've got one false conjunct in this row, so the conjunction is false. We've got one false conjunct, not C, so that's false. And then we've got both two true conjuncts, so that's going to be true. And then I'm just going to mess around slightly to improve the alignment of my truth table so that my truth value is lined up under the connective that it's applied to. You can see I'm doing this the lazy way with a lot of spaces, but it does the trick. Let's look at these rows. We're looking under the main connective, and under the main connective, that's the one that determines the truth value of this sentence. It's false. Well, we have a false conclusion, but we have one false premise, so this row can be checked off. And here we have a false conclusion, but again, we've got one false premise. So this row can be checked off. Now our truth table is complete. What do we conclude? Well, we should give an explanation of what we've learned. In this truth table, there are no rows where the premises are all true, but the conclusion is false. That means that this argument is valid. So we have a short explanation of what we can conclude from this truth table. And that's how you would do one that tests for validity.